regression models. Guys, before I'm going to talk about the regression models, generally yesterday we have already discussed about this, how the regression models generally work. Regression models work only based upon the quantitative continuous variable data. The quantitative variable which is holding the continuous data will be used for implementing any sort of regression models. As a part of it, we always try to understand a correlation between the two different variables, so-called X and Y. When we see a correlation, and then we will try to identify in order to predict the certain result at the end of the day, we have to understand the regression models in the very best way. So as a part of it, generally, whenever we wanted to understand a regression, we have a simple linear regression and multilinear regression and polynomial regression, etc., something like that. As we have an agenda, how we need to cover, as a part of it, let us cover the simple linear regression and the multiple linear regression. Take a look at this one. See, budget and the box office of one particular movie, of several movies, has a data budget versus box office. So the data was plotted is something like this, and the corresponding equation where we can draw a one particular line which could fit for this data should be derived from something like y is equal to beta naught plus beta 1x. Okay, y is equal to beta naught plus beta 1x. So now coming back, what are all these things? Beta naught plus beta 1x, if you can remember, we know the equation of the line y is equal to mx plus c. mx, m represents the slope of the line, c represents the intercept, hence this b naught, which is going to be a coefficient 0, and coefficient 1, which is going to be the beta 1, are none other than slope and the intercept. And x refers to the movie budget and y refers to the box office revenue. So if we know the values of the beta naught and beta 1, then we could clearly draw a one particular line which is going to be an exact fit for the given data. But we are unsure for the upcoming data whether this line exactly fits or not. That's a different story. We will talk about that one a little bit later. But for now, whatever the data that we are having or holding, this is how that we have understood that we can draw a line for the given data which is going to be an exact fit for the given points. See, beta is none other than, I told you, right, slope and intercept. The slope of the line, how much slope this line needs to be drawn, and the intercept. Understand, Narayana? Beta is a variable. Sorry, it's not a variable, it's a constant or the coefficient. Variables are x and y. Okay? Now take a look at this one. In order to predict 175 million gross here, which is located over here, for 160 million budget, See, this is how that we can parallel. If you just wanted to make it for 200 million budget, okay, how much gross that we can expect? Somewhere it is expected minimum. It needs to be somewhere around 200, more than 200 million, right or wrong? In the same way, take a look at this one. We have a different line drawn. Which model fits the best? See, this is a predicted value and this is the observed value. Means you need to see the green line shows these are all the predicted values. Okay. And what are all the observed values? Here are the observed values. So you can take the distance between these 2 points. Okay. You can take the difference between these 2 points. And sum of squares of these differences is generally called as so this is the formula basically in order to understand y hat. This is the y hat is none other than predicted value minus observed value. Once we identify that one, this is how the formula which is applicable for each and every point where it should be a sum, like y hat minus y bar minus y whole square, sum of, this is what we will call it as sum of square residuals. Okay, this is generally called as mean squared error. Okay, root mean squared error is none other than RMSE, minimum mean squared error. Okay, or cost function that we will call it as RMSE, root mean squared error. Based upon this one, we will try to understand how much error is that. Okay, based upon this one. All of you understand this? Any questions so far? So by looking at this, we can understand modeling this best practice. What is a modeling best practices? We need to understand the cost function or the whatever the mathematical material to fit the model best. Let us develop the multiple models and let us compare the results and choose the best one. So this is how that we will do that. What about the other models? See, we have something called the sum of squared errors, which will take y beta, means, I mean, we can take it as y hat minus y whole square. This is all mathematical stuff which we are not actually doing it. Rather, we are going to work on this one on Python by using the functions. So other measures of error, total sum of squares, but what is the famous sum of square errors is the famous, and we have some other even observations also which is called the total sum of the squares and correlation coefficient, which we have already done earlier. Okay, so let us try to understand how well that we can work on this particular simple linear regression model by doing one example. Okay, all of you, are you ready, guys? As a part of it, to execute that, I'm going to open the spider to create a one particular regression model. It will take some time to open. Narayana, did I answer your question about the beta? Why? Because do not get worried about the formulas that you can see over here. They might be representing some bad view about the concept. Rather, you concentrate about the subject. Okay. What I will do, once after we complete the entire regression models, I will just recap it again. Okay. with my oral explanation rather than showing you something like this, odd formulas. Okay, that will make you or clear you more much better. So let me just open the simple linear regression mode. So here we do have the simple linear regression model, where here we are trying to use a data set called salary underscore data.csv. What do we have inside this? See, guys, we have the data regarding salary based upon the years of experience. So if you can take a look at this one, I have imported the NumPy, Matplotlib, okay, and Pandas. We know all these things, and we have written a lot of programs on this. So I have imported, and I also tried reading the files data. See, it says like it does not exist. There was an error. Okay, fine, no issues. And let me just, why? Because there might not be valid path for this one. Let me just execute now. Uh, Otherwise, we can do one thing. We can set the working directory even otherwise, right? Now it is done. Okay. Anyhow, so now take a look at this one. X is equal to data set IOC. I've executed these things, and if you want to check what I have done, X value and Y value. So you can see the X value. So these are all the X values. Okay. 1.1 years, 1.3 years, 1.5 years, 2 years, 2.2 years. These are all the number of years of experience. Okay. Whereas Y represents the salary. Oh my God, what happened? This is a small letter. Okay. You can see this is a salary. So guys, here you need to understand one more thing, that I'm using the scikit-learn. Scikit-learn is a machine learning library where we are trying to use in order to execute in the Python. Okay. So first of all, when I wanted to work on this one first, let us segregate the data into two divisions. One is the training data and testing data. Training data, using the training data, we will try to create a model. Using the testing data, we will test that model. So as a part of it, let us try to understand from this one thing. From scikit-learn.cross validation import training underscore test split, where I have split the data across by using the random underscore state is equal to 0. Okay. And then coming down, coming down the line, I have imported something called a linear regression to, so you can clearly understand how easy it is to run a linear regression model in Python. So from scikit-learn dot linear underscore model, you can import a package called linear regression function from where you can regressor is equal to my variable name equal to linear regression. Linear regression is a function, and regressor dot fit where I'm giving the training data. Okay, whatever the training data that I have retrieved, execute that part. Okay. Each and every line can be executed over here, guys. Let me execute in such a sense. Executed this one, and God. Regressor dot fit, fitting the line. And now y is equal to predicting the test results. Done. Now I can see the results of the C. Predicting the test results, I can see y underscore predictions. So the test results basically. Apart from that one, you can always try checking this regressor.fit by assigning some variable abc equal to or reg model equal to. So I'm executing this part and then reg model to print. So how well it is done over there here. And I just want to draw a plot. You can see this is how the plot can be designed to see the set of points that we have explored. That is the best fit linear regression line. How that works with the test results. This is the test set data. The same model that we have used, okay, while doing this part, regressor dot predict x train. Okay. All of you, did you understand the model that we have created? Guys, this is how that we can go ahead with the linear regression example using the scikit-learn documentation of the Python. See guys, here we understood that yeah, I will explain you. But before that one, I just want you to understand how exactly how the coefficients are learned here. How do we understand the coefficients of this particular model? Right or wrong? So here, whatever you want, you can try checking that. I want something called coefficient. So this is the coefficient that I have got. For the value, if I wanted to check the mean square error, I can always check by using the mean underscore square square error of you need to provide. Yeah, it should be already imported over here. Where is this cycle? Okay, okay, it was not imported over here. Now let us try importing. It was just imported only linear regression. Okay, let us try importing mean underscore square underscore error, comma, r2 underscore square. And now let us try now. It will comes under the matrix actually. So this makes sense. SQL learn metrics. We have something called a matrix. Matrix consists a lot of information about the statistical variables and all stuff. So that is how that we have done this part. So we can always search it even if we are just moving out of the story. You can always check it out over here by looking at it. There is a lot of API support from the scikit-learn in terms of the machine learning. So as a part of it, let us try. We are trying to use this scikit-learn.metrics. So where is this scikit-learn metrics? Here is a mean squared error. Hmm. So let us use this part. So if you can take a look at this we can always see that how what the mean square error holds y underscore true and y underscore predictions. So based upon the given stuff, we are always interested to understand what are the variables or the arguments that we need to pass through. Okay, when we have created the test set over here, we have used something called y underscore prediction, right? So that one we are going to give it anyhow. That's a different story. And as a part of it, we are also interested to give the y underscore test also. Okay, y underscore text comma y underscore prediction. Okay, so here this is what that we are interested in to display. So let us try. We have the predictions, something like this. Okay, out of which where I just wanted to show this mean squared error of these particular two variables. We can also now do something. This is not providing us the valid data, and now let us try checking with the r square underscore wild score test wild score predictions r square. Two underscore score. This should be the one. Where we went wrong? Why? Because we are providing the valid y here. Why? Because we have. Shall we go ahead with the y train? Otherwise, y train. Let me just go ahead and execute this part. Yes. Why? Because inconsistent number of stuff. Why? Because we have used the Y train, which will not fit into this. The number of values are different. Y test, otherwise X text. To show you some values over here. This is how the predictions for the training data, and this is what that we have plotted over here. Okay, and here we also have x underscore test data. Basically, I need to change. This is the data, and where I have passed the same kind of story, and where this is going to be the my test data. Okay, so but I just wanted to. I'm interested much to show you about this individual understanding about the coefficients, which is very important over here. So as a part of it, let me first show you this scales and all. Okay, how well that we can estimate this coefficients. Estimation of these coefficients are very much important in this, rather than looking at the numbers. Why? Because y is equal to mx plus c, whereas m refers to the slope and c refers to the intercept, means beta 1 and beta naught, where beta naught refers to the intercept and beta 1 refers to the slope. Here we need to understand what are the coefficients over there, and if we understand the coefficients, then we can understand what exactly is happening with that. Okay, otherwise we can go ahead with the model summary. Dot, even this way we can get that. For this one, I think we need to import something like from stats models dot API import sm, and then we need to use a different model over here, which I don't want it, and I don't want to confuse again. So why? Because we need to create a different model over here, and then we need to make a fit, and we need to get the summary of the results. But I just want to show you only the linear regression model, which is there in the scikit-learn. Okay, so hence I will just check it, and I will just show you that only coefficients model in the different kind of summary. Okay, as soon as, I mean, as much as possible, let us try importing the whatever it is necessary for us, rather than importing everything. Okay, so even here in the main squared error, I will just take a look at this one. Why is it not raw values? That is fine. It is, even if you are not going to pull it up, it is not a problem. Here we do have the, what else that we are doing mistake over here, y underscore true comma y underscore predictions. This is how that we have passed over here. Look at this one. See, and I just wanted to give mean underscore squared underscore error of hmm, guys y underscore underscore not test comma. Yeah, here we got it now. Okay, So this is how that we need to check. This is how that we have got the squared error, root mean squared error. Okay, and also you can see the r square model for the same linear regression. R2 score matrix. This is why that we are unable to get it. Why? Because it has already imported the matrix. Okay. Even that we haven't get taken the matrix, but still let us try. R2 underscore score R2 underscore score of okay. Now I think we could get the score. It's defined there. We got it. Why? Because we need to execute from the first in the spider. So now you can see the R square model. The model is 0.97, which is a 97 percentage is the accuracy of the model. 97 percentage is the accuracy. Okay. Understand, guys? So we will discuss this one a bit more detail in the multiple linear regression model when we are working with the multiple linear regression model. Okay. And then you can work on the same thing. Okay. We will meet again tomorrow to explore the multiple linear regression model, and then we will work on that. Okay. See you all tomorrow. Bye. Yeah, I'm sorry. Yeah, we will meet again Monday morning, 8 o'clock. Okay. Bye.